Assalamu alaikum everyone. My name is Fizan Ali Software Wala and I'm a level 1 student at Rehan School Islamabad campus. So today I'm here with a new Maya. So our today's Maya topic is what are the atoms and why are the building blocks of everything. So please keep so let's start our today's Maya. First of all, call the Maya for some questions. So let's start.
Hey, how are you doing?
Okay, so my first question from you is what exactly is an atom and how was the concept of atoms discovered? So please give me a very interesting answer on this topic. So let's start. Okay, so my first question from you is
Hi, what's up?
Maya. My first question from you is that what exactly is an atom and how was the concept of atom discovered? Please give me a very interesting answer on this topic. So let's.
Okay, so an atom is basically the tiniest unit of matter that retains the chemical properties of an element. Everything around us, you, me, your phone, everything is made of atoms. They're super small, like unimaginable, and they're composed of protons, neutrons, and electrons. Proton neutrons hang out in the nucleus, which is core. An electron whiz around the nucleus in something called electron shells, or the number of protons determines what element it is. Like all atoms with one proton are hydrogen, two protons are helium, and so on. As for how the concept was discovered, it's a long story. It actually goes back to ancient Greece around 400 BC with it to a point where you couldn't cut it anymore. They called these indivisible particles atomos, which means uncuttable. Pretty smart for that time, right? But here's the thing, it was just philosophical speculation back then. It took centuries before there was any actual proof. That finally started happening in the early 1800s with John Dalton. Hey,
Okay, we was having a network issue, so I again called the Maya for some questions. Hello Maya, how are you? Okay,
hey, hey.
Maya, please continue answer. So my question from you is what are atoms considered the smallest unit of matter? So very interesting answer on this topic. So let's start your answer, Maya. Okay, so you was having a network issue, so again call the Maya. Okay, so Maya, please give me answer. What are atoms considered the smallest unit of matter? So please give me answer on this topic.
Hi, what's up? Okay. So an atom basically the tiniest unit of matter that still has the properties of a chemical element. Everything around us, you, me, your phone, everything, is made of atoms. They're super small, like unimaginably small, and they're made up of protons, neutrons, and electrons. Protons and neutrons hang in the center of the atom, which we call the nucleus, while electrons whiz around the nucleus in different patterns. The number of protons determines what element it is. All atoms with one proton are hydrogen, two protons are helium, and so on. As for how people figured this out, it's a pretty long story. It actually started way back in ancient Greece around 400 BC with these guys Democritus and Leutonpis. They thought that if you just kept cutting something in half over and over, you'd eventually get to something you couldn't cut anymore. And they called these ultimate particumos, which means uncuttable in Greek. Pretty smart for that time, right? But here's the thing, it was just a philosophical idea centuries before anyone could actually.
Viewers, please sorry to say my network issue. So, my next question, Maya.
Hey.
So, Maya, first, my next question from me: what are the main atomic? What are the? How do atomic structure affect activity? So, please give me a very interesting answer on this topic. So, to answer Maya, question from you is how do atomic structures
Okay, so
affect conductivity? Please give me answer on topic. So, let's start.
atomic structure is the heart of why some materials conduct electricity easily and others don't. It all comes down to electrons, those tiny particles orbiting the nucleus. Conductivity is about how easily electrons move through a material. There are three main types of materials: conductors, insulators, and semiconductors, and their atomic structure dictates which category they fall into. Let's start with conductors like copper or gold. Their atoms have loosely held valence electrons. That's the outermost electron shell. These electrons aren't really attached to any specific atom. They're delocalized, meaning they roam freely throughout the material. When you apply voltage, these free electrons can move around easily, creating electric current. Insulators like rubber or glass have valence electrons. Their electrons are locked in place and can't roam around. Because electrons can't move, they don't conduct electricity well. Now, semiconductors like silicon are somewhere in between. Their electrons are less tightly bound than in insulators, but not completely free like in conductors. In semiconductors, you can control their electrical properties by adding dopants, which can change the number of free electrons or create holes for electrons to move into. Atoms aren't these simple spheres with electrons floating around, though. Their arrangement matters. Crystal structure is important because electrons encounter less interference as they move through a neat and organized array compared to jumbled atoms. Also, the electron bands, the energy levels available to the electrons, overlap differently in conductors, insulators, and semiconductors. Conductors have partially filled bands, allowing electrons to move easily. Insulators have full bands with large gaps between them, which makes electron hopping harder. That's why temperature matters. It can mess with atomic arrangement. Does that give you a good start?
So, Maya,
Are you still
my
there?
next question,
Just checking in.
my next question from you is: what role do atoms play in chemical reactions? Please give me very interesting answer on this topic.
Okay, chemical reactions are basically atoms rearranging themselves to form new substances. They're the fundamentals driving everything from rust forming on metal to digestion. The key thing to understand is that atoms themselves don't change during a reaction. They just get shuffled around. But their behavior during this shuffle is fascinating. First, atoms have this drive to achieve a stable electron configuration, usually aiming for a full outer shell like the noble gases. That's why they form chemical bonds. They're basically trying to complete their electron puzzle by sharing, donating, or accepting electrons. There are a few major types of bonds: covalent, where atoms share electrons, like in water or methane; ionic, where electrons are transferred, resulting in ions that attract each other, like in table salt; and metallic, where electrons are pooled and shared freely between many atoms, like in metals. When reactions happen, atoms need to collide, but not just any collision will work. The molecules must have enough energy to break existing bonds and form new ones. Think of it like trying to push furniture around. If you don't push hard enough, it won't move. This minimum energy needed for reaction is called activation energy, and it's hugely affected by things like temperature and catalysts. Catalysts are basically reaction helpers. They lower activation energy. Also, reaction rate depends on things like concentration, surface area, and pressure. The more atoms or molecules packed into a space, the more likely they are to bump into each other and react. Surface area matters because reactions happen at interfaces, so crushing something up increases its reactivity. Think of a wooden log versus sawdust, which would catch fire faster. The reactants also dictate what happens. Some reactions happen really quickly, like explosion reactions, whereas some reactions take ages. Reactions tend to follow law of conservation of mass. Matter isn't created or destroyed, it just transforms. What kind of chemical reactions are you curious about? Hey, everything okay? Still there? All right, I'll just be here when you're ready to chat. No rush.
Maya, my next question from you is that why do some atoms react easily while others do not, and how do atomic mass influence physical properties? So please give me a very interesting answer on this topic. So let's start your answer, Maya.
Good questions. It's totally true that some atoms are way more reactive than others. That mostly comes down to their valence electrons, how they're arranged, and how many they have. Elements like sodium or potassium have just one valence electron and are happy to dump it to become stable, which makes them super reactive, especially with water. Noble gases like helium or neon already have filled outer shells, so they're basically content and won't react with anything unless you get really extreme with energy. Their electron configurations are so stable, they're considered inert. Now, atomic mass and physical properties, there's a real connection. The larger the atomic mass, generally, the stronger the forces holding the nucleus together, those strong nuclear forces. Mass also impacts properties like density and melting point. Heavier atoms pack more mass into the same space, so density increases as you go down the periodic table. Also, the mass influences intermolecular forces like van der Waals forces or London dispersion forces. They get stronger with larger atomic mass, raising boiling and melting points. Heavier atoms also have more electrons, creating larger and more diffuse electron clouds around atoms. These larger electron clouds increase the ease of polarization, so interactions are stronger. Take mercury versus water. Mercury is much denser because of its heavier atoms. Also, atomic mass affects the size of an atom. Larger masses correlate with larger atomic radii. The size influences properties like conductivity, reactivity, and even color in certain compounds. Other factors like atomic arrangement, electron configuration, and bonding types all play a part. Does that make sense?
It was my network issue. So my next question from you is, what is the periodic table and how it's organized, and why are noble gases so are active? So please give me an interesting answer on this topic. So let's start your answer.
Hey! No worries. Let's cover both those questions quickly. The periodic table is basically an organized map of all known elements arranged by their atomic number, which is the number of protons.
It was wait for a few minutes. I again reconnect to Maya. Section is very bad because having a network issue. जल्दी कैसे जमा करें ये देखो इसको सेंड करना हमने माया का मोबाइल है Okay, so this was our today's new Maya session. Okay, so Maya, please connect it. Okay, so Maya, my first question from you: how do atoms from acids and bases? Please give me long answer on this topic. So let's start your answers or interesting answers.
Hey, hey. I'm here. What question did your friends give you? Oh, okay. So you want to know how atoms from acids and bases interact? That's a really interesting question. It gets into some pretty fundamental chemistry. It's not really about adding atoms directly. It's more about how they combine to form molecules and then how those molecules interact with each other. Here's the breakdown. Acids and bases have very different atomic arrangements. Acids generally have hydrogen atoms that can be donated. They're kind of loose and eager to participate in chemical reactions. A classic example is hydrochloric acid, HCl. You've got one hydrogen atom and one chlorine atom bonded together. The hydrogen is the key. It's the acidic part. Bases, on the other hand, tend to grab those hydrogen atoms. They often contain oxygen or nitrogen atoms that have lone pairs of electrons. They're like magnetic attractors for positively charged hydrogen ions. Sodium hydroxide, NaOH, is a good example. You have sodium, oxygen, and hydrogen. The oxygen-hydrogen connection is the reactive part here. So what happens when you mix an acid and a base? A neutralization reaction. The hydrogen atom from the acid gets transferred to the base. In our example with HCl and an AOH, the hydrogen from HCl moves to that hydroxide part of an AOH, forming water. What's left are sodium and chloride ions that form salt. Sodium chloride. Essentially, the acid and base atoms rearrange to create completely new molecules, water and salt. It's a bit like taking apart two building blocks and using those pieces to build something new. The atoms themselves don't just randomly combine. It's all based on how many electrons each atom has and how stable they want to be. Hydrogen wants to share or give up its single electron, while oxygen and nitrogen atoms want electrons from others. Their atomic structures or electron configurations determine whether atoms readily give away or steal electrons. This whole process happens because molecules seek the most stable arrangement possible, like building with Legos. Atoms combine in ways that create the sturdiest, most secure structures. Does that make sense? You still there? Sometimes the audio connection gets a little choppy. Just checking you can hear me okay? Hey, everything all right? Still with me? You don't need to respond right now. Just let me know if you're having connection issues.
So we were just was Maya. Oh, you hope you like it. I meet with the new Maya next topic. Thank you, Anurag. Pakistan Zindabad, and thank you.